Hello, ladies and gentlemen, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today will demonstrate how to leverage the AWS Cloud for event transcoding and distribution. I'm your host, Maya Kabasi, with the Partner Marketing team here in Seattle. I'd like to start with a couple of housekeeping items. We are recording today's webinar, and while lines are muted, you can submit questions anytime during the presentation. Use the Q&A widget in your browser to do so. We'll take time for questions at the close of the webcast. In addition, this presentation will be available for on-demand. You may find our webinar recording and materials available on AWS YouTube channel. I am pleased to be joined by Matthew McClure, Encoder Developer Evangelist with Bright Cove, and John Mancuso, Solutions Architect with Amazon Web Services. On the agenda, introduction to Amazon Web Services and overview of Amazon CloudFront for content delivery, and then an overview of Encoder and how to leverage the cloud to scale live stream transcoding. We will begin today with John Mancuso, who will talk about Amazon CloudFront. Then we'll pass the mic to Matthew McClure, who will show a demo presentation of Encoder. We'll wrap up with a Q&A. So without further delay, let me turn it over to John Mancuso, Solutions Architect with Amazon Web Services. Take it away, John.
Thank you, Maya. Hi, I'm John Mancuso, Solutions Architect with Amazon Web Services, as Maya said. And what I'm going to talk about a little bit today is how you can leverage AWS for your live event distribution. So I'm going to give you a little bit of a preview, primer on what AWS actually is, and then talk about some of the specific services that you would leverage to do your live event transcoding and distribution, and pass it over to Matt. So one of the first questions that we always get whenever we talk about Amazon Web Services is how did Amazon get into cloud computing? So the short story is that approximately 10 years ago, Amazon.com, the retail business, started embracing service-oriented architectures. And in doing so, we developed separate product teams to release, to deliver new features and enhancements to Amazon.com's retail site. Each of these separate product teams it turned out that each of these separate product teams would have common needs and asks. Many of them would ask for things like compute and storage and other IT-related services. And so what Amazon decided to do was build a set of shared services to deliver these types of things. So once we did that, it made it much more efficient for these product teams to be able to roll out their own services. And in doing so, we asked ourselves if this was useful for Amazon as a whole, would it be possible that other customers would also be interested in this type of thing? So that really was the birth of Amazon Web Services, the ability to provide IT-related services to consumers on demand. So what is Amazon Web Services? Well, you could think of it as two things. First, a set of global infrastructure, and within that set of global infrastructure are a number of different services that you can consume to meet your IT needs. So our global infrastructure is made up of a number of what we call regions, availability zones, and edge locations. If you look at this map, you'll see the large boxes represent our regions, the small boxes are availability zones, and the stars are edge locations. So what a region is a collection of data centers, and we refer to those data centers as availability zones. And so if you consume services that are in multiple availability zones, you'll know that you're putting things into isolated data centers within one of these regions. And in terms of the edge locations, we'll talk about that a little later when we look specifically at CloudFront, our content delivery network. So what is available in some of these regions? Well, like I said, it's a collection of services that you can leverage to deploy your applications to. So examples of these services are things like compute, which is Amazon EC2, and for storage, we have Amazon S3, Simple Storage Service, and Glacier. And a little bit further up the stack, we have our content delivery network, CloudFront. So the specific services that I'm going to focus on today related to live event transcoding and distribution is Amazon S3 for storage, Amazon Glacier also for storage, and content delivery with CloudFront. So what is Amazon S3, Simple Storage Service? It's what we refer to as object storage, and an object is really what we call is made up of a key and a value, and the key is you could think of as the file name, and the value is the collection of bits that make up the file. So in this use case that we're going to be showing you today for live event transcoding and distribution, what Encoder is going to be doing, our partner on this call, is going to be taking in your live stream, doing the transcoding, and storing the chunks that are generated via their transcode process on Amazon S3 for delivery. And one of the reasons why they leverage S3 is because it's highly scalable, reliable, fast, and durable. And it's natively online on the internet. So there's nothing that you need to do to publish a file other than make sure that the permissions are set appropriately. So why do you care about the scalability, reliability, and durability? Well, one, when you're doing your live streaming, you want to make sure that the stream is going to be available to all the viewers. You want to so you don't, by leveraging S3, you won't have to consider things like a disk failure. In terms of being highly scalable, if your live event is, let's say, broadcasted to tens of thousands or hundreds of thousands of viewers, you want to make sure that the storage subsystem that you're using is capable of scaling that way. And with S3, you get all those things. So once your event is completed, what you'll end up with is a number of these segments, of the video segments. Usually, it can add up. The numbers can add up quite large, depending on the duration of the event, and oftentimes you won't need those chunks, but maybe you'd like to preserve them for some reason. And if you do, maybe you want to show a webinar or replay your live event months down the road, and you'd like to use the segmented format that was originally used, you could archive to Amazon Glacier. And what Amazon Glacier is an extremely low-cost version of storage, and one of the reasons that we can make it so low-cost is because there's a longer time to get the file, any files that you're requesting. So with S3, when you make a request for a file, it's available immediately. There's no delays. With Amazon Glacier, you'd have to wait 3 to 4 hours to get the file back. So for archival, it's a perfect storage solution, and the price point is in the order of, or is typically 1 cent per gig per month, which is extremely low for the type of storage that you're getting with Glacier. So now that you know that you'll store your video fragments in S3 and archive them in Glacier, you want to think about how to deliver the video to your end viewers. And one of the ways that we would recommend that you do that is to leverage a CDN. So what is a CDN? You might ask first. Well, a CDN is a content delivery network, and it uses a network of geographically dispersed servers, also referred to as edge locations or POPs, to cache copies of content close to end users, lowering latency when they download or stream objects. So just to pick out a few key terms in that definition, geographically dispersed. So if you remember back from that original slide, those stars that you saw for our edge locations are located around the globe. And the reason that you'd want that is whenever a viewer of your content or of your live stream is requesting the stream, you'll want to have the server that responds to that request be as close to the end user as possible. And so that's why we have a number of these edge locations around the globe. And what those servers are doing in these edge locations are caching copies of the content. So as the stream is progressing, the fragments can live temporarily anyway on the edge servers that are closest to the viewer. And the end result of this is that when somebody is watching a video, they'll get less jitter, or be able to see the videos, see the stream in closer to real time than if they were going directly to S3 or any other video origin. So to dig a little bit further into what CloudFront is, and we'll see Matt will be doing a demo of how to configure CloudFront distribution a little later. But for reference, there's a couple of terms that we'll want to define for you. And in Amazon CloudFront, the two terms that you'll want to be aware of are distribution and origin. And so what a distribution is basically a set of rules that determines how CloudFront will access your content, in this case the live stream output, and the origin will be the actual source of that content. So that's where you'll specify your S3 location. And to just take a quick run through of how this actually works, imagine that you have a site viewer somewhere far away from your origin. So let's say you're running this stream. I think Matt is running the stream out of his San Francisco office or thereabouts, and he'll be publishing that to our S3 region in Northern California. So imagine a site viewer is coming to that, is requesting the stream from let's say Sydney, Australia. What they'll do, and what that person would do if they're going through CloudFront, is to hit our CloudFront edge location, and we will automatically route that person to the nearest edge location based on latency, and so that would likely be in Sydney. If that edge location has not determined that it has a copy of the content, what it'll do, it'll make a request back to our region in Northern California in S3, get the object, and as it's storing the object in the cache locally, it'll also start delivering it to that person. Now, another person, let's say, who's coming online from Sydney, also viewing the stream, it could be a fraction of a second later, or a minute later even, but in a live streaming example, it most likely would be just a few fractions of a second later. And in that case, CloudFront will not have to go back to S3 to get the object. It'll simply serve it right out of the edge location that's local and give the best performance for that end user. So what are the common ways that customers leverage Amazon CloudFront? Oftentimes it's for media delivery, things like video and audio. Also large file delivery, software downloads, and just any kinds of web assets like images, CSS files, and JavaScript files. It's useful for all these things because it can lower latency of delivery. Also gaining a lot of popularity is customers wanting to leverage CloudFront for dynamic content because of optimizations that we'll talk about in a minute. And then lastly, what we're talking about today is really live streaming, so things like sporting events, corporate meetings, and events. So Matt will be taking us through the whole process of how to set up a live stream with CloudFront and S3 in a bit. What are some of the benefits of using CloudFront? Definitely faster. We've talked about that because it's closer to your end users, and so it's simply long distance plus poor network equals slow load times. But if you leverage CloudFront, you're getting really short distance and an optimized network, which will give you the fast load times. So if we just take another look at what the map looked like, you'll see lots of edge locations in North America, lots in Europe and Asia as well, and also South America and Australia. So we feel like we have the globe pretty well covered into many of the areas that people are requesting content from. And we're constantly expanding this network as well. So if you have a need to be somewhere that we're not, please let us know. And very briefly, in addition to just being closer to the end users, we're also doing things like optimizing window sizes for TCP/IP connections, and we're maintaining persistent connections between CloudFront and the origin to minimize CPU, the CPU needs from the origin to maintain multiple connections. From a scalability perspective, CloudFront can definitely give you a lot of benefits as well. And I think I'm actually going to skip past a few of the slides here just to give Matt the time that he needs. So bear with me one second. From a scalability perspective, the main things to understand is that CloudFront really can absorb a lot of the traffic that would otherwise hit your origin. For today's session, it's not as important because S3 can scale tremendously on its own, but it still does provide many benefits there. CloudFront's also extremely easy to manage, especially as compared to a number of other CDNs, because it's completely self-service. It's up to you to configure it entirely on your own. You don't have to call anybody to do that. And lastly, it can also make your applications cost less because there are special pricing benefits. If you're using a lot of data transfer through CloudFront, you can get lower data transfer rates than if you were going directly, let's say, out of EC2. So to jump ahead just a little bit here to how customers typically do live streaming, or in the past have done live streaming with AWS. What they would do is deploy what we call a media server stack, and that would be something like Adobe Media Server or Wowza Media Server, and they would deploy that on Amazon EC2. And to do that would require knowledge of both that product, let's say those products, either Adobe Media Server or Wowza Media Server, and knowledge of EC2, and knowledge of, let's say whatever operating system that was running on, maybe possibly Linux, and so on. And so what we found is that this may have been a great option for companies who have lots of experience doing those types of things, but many people in the media space know about video, and so they would prefer to have a fully managed solution, one where they don't have to think about those things, about Linux and Adobe Media Server, and how to make their stack highly available and scalable. And so that's what Encoder really is bringing to the table. Their model is quite simply take an input stream, publish it to their endpoints, do a little bit of configuration via their API or via their API, and in the end you'll get an output stream that you can put a CDN like Amazon CloudFront in front of for delivery. So with that, let me pass it over to Matt.
Thanks, John. So as he said, I'm Matt McClure. I'm with Brightcove, specifically on the Encoder team. But so before we get started, because CloudFront distributions can take a few minutes to propagate, we'll go ahead and set one up now. And actually, full disclosure, I've already pretty much set one up, and that's the one I'm going to be using. But just to talk about the process real quick. So if you go to your AWS Management Console, and then you see this CloudFront distributions, right? So this is the one I already have. This is what I'll be using today. But if you were to create a new distribution, you'd see these two options, download and streaming. You might be tempted to select streaming, but this is going to be used more for RTMP streams, which is not what we want here. So download is what we want because these are actually just files transferred over HTTP, so there's no need for anything special there. So once you are actually setting up your origin, you'll see a list of your S3 buckets you have available. So I've already got one set up, as I said, but so if I were to set this, it's already going to set my origin ID. You can set restrict bucket access, which means your users will only be able to access the contents of that bucket through your CloudFront URL. So we'll say no because we want to access it from both. How you want them to be able to view it. Most of these can stay the default settings. The other ones that you might find useful setting up something like this would be what price class you want to use. So for instance, we're probably only going to be having US and Europe viewers for our instance. So we select something like that. And then we could say set up an alternate domain name. So instead of some string generated by CloudFront, you could point your users to a stream coming from your domain, which can be cool. And then a root object, so say you have an index.html file, this is what will get served to your viewers first if they don't specify any paths. So then once you're ready to go, then you could just say leave the distribution state as enabled and create distribution. And usually I've seen it in about 15 minutes. That distribution will be ready. So as I said, we're not going to actually create one now because we've already got one ready for us. But those are the steps that I took in creating this distribution. So just a little background about myself and Brightcove. So once again, I work for Brightcove, specifically on the Encoder team. And Brightcove pretty much does everything you could want around the distribution and monetization of video, particularly on the web. So I'm specifically on the Encoder team, which is one of the suite of products that Brightcove provides. And we do just video transcoding via API. So live and VOD assets. But the live product is what we'll be talking about today. So just a little background about the streaming protocols that we're talking about here. You might have noticed that I mentioned RTMP before as the streaming protocol when you're setting up these things. So RTMP is the other way of streaming at this point. HLS and RTMP are kind of the big dogs in the fight at the moment. And RTMP is originally developed by Macromedia, so now it's an Adobe product. And it was intended for playback in Flash, but the kicker here is that it requires special RTMP server endpoints. So this could be something like Flash Media Server, Wowza, or Red5. And as John said, this is kind of that crazy stack that he was showing, where you'd need to set up these scaling EC2 instances that would take in an RTMP endpoint, and then transcode that to maybe other, it could possibly transcode that to other formats and renditions, and then your viewers would access those Wowza instances directly or with a CDN in front. But either way, it's difficult to scale, and it requires all the special server software. So HLS is kind of a much easier, quicker way to get started. And so this is HTTP live streaming, and it was most recently implemented by Apple as part of QuickTime and their iOS products. And so, as I said, the really awesome thing about getting started with live streaming in HLS is that no special server software is required. So all that HLS consists of is a bunch of very small segments of video, and then a manifest file. This is just an M3U8. If you ever used, say, like Winamp, and you had a playlist of audio files, and it was an M3U8. So that's all this is just an M3U8 playlist with live events. We just append new items to that playlist, and those all point to a file. So file1.ts, file2.ts. So those are, and the player downloads that segment, or downloads the manifest, and then plays each segment as it comes to that point in the manifest file. So here's an example of a manifest. As I said, it's actually really awesome when it comes to modification, because you don't actually have to modify anything about the video itself. You can modify your live stream or modify any HLS asset by just modifying this manifest file. And so as I said, it's just the playlist type, the target duration of each segment, and then you have the xint that you see there is the duration of that segment, and then the segment name. So super easy in terms of a plain text format, but it's really great to get started. So this is what the client would download, like say an iPhone or QuickTime. This is the actual file that they would download, and then as it goes through the file, it would just play back the segment listed there. So the live streaming to S3 setup, once again, for a little bit of background, you could publish, well, I'll get to that in a second. So we've got a camera, so anything will do, but a webcam would be nice in our use case. You'll need encoding software. So we'll be using Flash Media Live Encoder, but there are other great options such as OBS or Wirecast. XSplit is one that's used a lot for like gaming streaming. But so we'll be using FMLE. And so you'll also need an AWS account for the S3 and CloudFront aspects. And then you'll need a Zencoder account with a live subscription or something like this. So this is what I was referring to a second ago. The overall process looks a little bit like this. You would send an API request to Zencoder. Zencoder will respond to that request with a stream URL and name. And so you start publishing an RTMP stream to that. And then we, on our side, will automatically scale to whatever we need to, transcode that input file, or that input stream into all the different renditions that you selected. So up to 20 RTMP and HLS output. And static assets. We'll get to that in a second. But so we'll start transcoding those streams live, and then publishing them to the output you specified, which can be any CDN. In this case, we're publishing to S3, and then we have a CloudFront distribution in front of that. And so then that's whatever you output to. That's the URL you would give to your users to actually view. There we go. So let's go through a quick demo of how this process would look. So we have our CloudFront distribution already set up, and I've already got this S3 bucket set up as well. So what I've done is just set up a basic script. So we have integration libraries for Ruby, Node, PHP, and a few others. But so I personally am a big Node fan, so I just wrote a simple little script that uses our integration library and then does some stuff like set up a folder name if one isn't passed in, and then an output URL. So we're using this S3 bucket that we set up already, and then it just creates. This is the API request. So essentially, this is a really thin wrapper around actually sending a post request to the Encoder API. So this is how a live API request looks. We have live stream true. Normally in our VOD for VOD files, as traditionally uses Encoder, you would specify an input URL, and then we would download that URL and transcode it into the output specified in this outputs array. So for live jobs, you just specify live stream true, and then just like before, you set up this array of outputs. So here we just have 3 different HLS outputs, a 300, 600, and 1200 bit rate rendition. And so then at the bottom of this, we have this master, and that's the master manifest. So each one of these outputs produces its own M3 weight manifest file, and this master playlist puts them all together and provides adapted bitrate streaming. So the user from their mobile device or desktop would download this master manifest, and then based on their available bandwidth, would select the appropriate rendition from above. So if they're on a really low quality connection, then they'll probably use the 300 kilobit. But if they're on a broadband connection, they could use the highest, or this 1200. So these headers, we'll get into those in a second. But these are pretty important for when you're using a CDN with HLS, particularly with CloudFront and S3. So public read says that right when I upload this file to S3, I want it to be publicly available. And then this cache control just says I only want the max age of this thing to be this long. So we have it set really small here because we don't want the manifest file to be cached for too long. It needs to be available as soon as new segments are available, because the client is just going to keep querying for this manifest file. So before I set this, what I was noticing is clients would just keep getting this old manifest and it would never update. So just a little heads up there if you want to start doing something like this. So we'll just run this script. And in the background, we're sending a post request to Encoder with that information. As I said, I've just printed this stuff out a little prettier, but we have the RTMP stream URL and the RTMP stream name. So that's what we'll actually stream to. And then we have this list of HLS outputs. So these are the 3 renditions. And then this is the master manifest that actually the user downloads to choose one of those renditions from above. So we'll go ahead and take this RTMP stream URL. And then we'll take the stream name. And we just connect. They're already connected. And then we click Start. And we're pushing. So we're pushing a live stream to Encoder. In the background, Encoder is transcoding this live stream. We've scaled up the appropriate workers to do that. And then we would publish those to the CDN of your choice, so S3 at this time. So just give me a little bit longer to go ahead and get started. But what we typically see is about, especially to S3, is about 20 seconds of latency, give or take. So sometimes it can be as low as 15 or 16, but that's kind of on the much lower side. Generally, it's around 22 to 23 seconds of latency. So what you would give your users, as I said, is this master playlist, which includes the other 3. So there you go. Now we've got this live stream. It's been transcoded through Encoder. publish to S3. Wow, I'm very animated when I talk. I didn't know that. So it's been transcoded live via Encoder, published to S3, and then so far we haven't touched CloudFront yet. But, okay, so if we wanted to add CloudFront to the mix, then you could optionally create a new CNAME subdomain for your event. As I said, that's when we were walking through the setup process, and you see this CNAME there. You could specify your own URL and set the CNAME to your CloudFront distribution, and then users could go there instead of some dynamically generated CloudFront URL, which can really help experience. So we create this new CloudFront distribution, optionally using that CNAME, and then you just follow the previous stream setup as before. And then the only difference in the workflow is that you point users to this new CloudFront location. It's awesomely easy and straightforward. So just to prove the point, we're still streaming to this URL right now. All we're doing is publishing to this S3 bucket. So the same URL works, but what we can do is instead of giving them that S3 bucket, like you see here, I set up a CNAME for just a personal domain that I have lying around, htbx.net, live.htbx.net. So I can say live.htbx.net and then paste in the stream name. So instead of the S3 bucket as the bait root URL, it's just the CNAME location. And voila, we're publishing a live stream to S3, and then actually right now we're getting that from CloudFront instead of directly from S3. Sorry. I don't know about you, but I call that a huge success. It's incredibly simple to get started. So the hardest part is actually getting started with S3. Once you get there, adding CloudFront to the mix is incredibly easy, and then you have this awesome distribution network at your fingertips. So if we wanted to add a VOD asset, so as John said, there's this great Glacier, this idea of Glacier. So you do a live stream, maybe you provide that, you create a VOD asset off of the live stream, and then you can provide that to your users, say like the next month or something. But then after a month, it's kind of old content. Probably nobody's going to watch it, but you might want to show it next year around the same time, say it was like a Christmas special. Then you just pull that out of Glacier, and you can use that VOD asset again. So setting up that VOD asset is pretty straightforward as well. So you have this array of outputs as before. To add a VOD asset to that, we just create a new output. I'll just go ahead and copy this to make things a little bit easier. And that's it. Let's go ahead and validate the JSON. So, oh no, I just realized I wasn't live streaming that whole time. Sorry, this is what I was doing. The only difference from what was before, this is the original API request. This is an API request, a live API request with a VOD asset. So as soon as the live stream is done, what we'll do is take that stream that we were working on, and then we'll just transcode that to whatever output you want. So if you wanted the raw FLV file, like the exact live stream that we had with no transcoding, then you could just do a transfer-only job, and we'll provide you that FLV directly. That would literally be the exact input that we received. But in this case, this will create a H.264 with AAC audio in an MP4 wrapper container. So yeah, and then we'll upload this to the same location we uploaded the live streams. So in that same bucket, you would just see awesome archive.mp4. So as I said, this is what you saw before. We just have live stream true, the outputs. If you want a archived asset, just include that as one of those outputs, just as you normally would. And when the stream is done, we'll create this. We'll transcode the stream into that asset for you and transfer it to the location specified. So if you wanted to get started and play with this, the easiest way, and you don't want to deal with making that node script or whatever, then you could just go to our request builder. So once you create an account, under the API tab, you can find this request builder, which will just let you paste in request bodies and execute them right there from the browser, which can be a really easy, great way to get started. We even have a live stream to S3 preset right in there. So you could just select that from the drop-down menu of job templates, replace the your S3 bucket instances with your own S3 bucket, and you could just do this exact same process. So that's all I have for you guys today. I think I'm going to pass it back over to Maya, and then we can possibly go over some questions. So thanks.
All right, Matt, thank you. And thank you all for demonstrating how to leverage the AWS Cloud for event transcoding and distribution. Let's open it up for a Q&A, and I already said that we have plenty of questions. If we don't get to answer them all, you will hear back from Matt via email mostly, and your questions will be answered. So let's start with, does Encoder live transcoding support live HDS, HTTP streaming outputs in addition to HLS? And Matt, I would like to point this question to you.
So no, at this time we don't support HDS. It's on our roadmap. I can't give any specifics at this time, but it's definitely something that we'd like to add as an output shortly.
Thank you, Matt. And moving on to another question. How about Android streaming? Does it work too?
Sure. So you would just publish the same RTP and HLS streams, and then how you consume those is kind of up to you. So we have these native player SDKs. I think they're under the Video Cloud title, so you need to go to Branko's main website. But we have these native video SDKs that will allow you to build native applications and consume video, and that includes HLS. And RTP is pretty easy to do too in native applications. For browser, for viewing live streams in the browser on Android, that gets a little bit ickier. On older devices that support Flash, you could do it. You could use RTP in a Flash player. For newer devices, there's kind of this weird tango with HLS that Android's been doing, where they officially announced support in the Android platform for HLS in 3.2, but it was really spotty in terms of which device you were on. And so then it's officially been dropped in 4.2. But rumor has it they've added it actually in the Chrome. Like the HLS player is now available in Chrome itself on Android. I have not been able to test this myself because I don't have an Android device personally, but I've heard from other people that it works quite well. So I think HLS is an awesome format, especially because of how malleable that manifest file is. So I'd love to see more people using it. I think Dash is probably going to make waves further down the road in terms of the Android world. And Dash is something else we're really interested in. There's just not a terrible amount of need for it at this time. So, but yes, the same streams that you use, that was a really long way of saying, the same streams that you use for Android and desktop, or iOS and desktop, can work just fine on Android as well, if you put a little work into it, essentially.
Thank you, Matt. Let's look at one more question. If I have a live conference event and I need to broadcast several lectures, starting and stopping the live RTMP uplink about every hour, do I have to make a new Encoder API request for each lecture? Can I just create one API request?
So it kind of depends on your use case here. If you have a live conference event and you don't mind just having that go, having one continuous stream, you can stream for up to 12 hours, and a little bit more if necessary. But we officially support up to 12-hour events. So yeah, you could just create one live event and then reconnect and disconnect from that as necessary. So there's some API settings such as event length and reconnect time. So say your conference was 6 hours long and you knew for a fact you were going to be streaming for 6 hours, then you could set event length to 6 hours and then disconnect and reconnect as many times as you want for as long as you want during that 6-hour time period, and it would be just fine. We'll hold open that stream URL and name for you for the entire 6 hours. The other option you could do is if you know that there's a 30-minute break between each one, then you could set a reconnect time of 30 minutes, and then you have 30 minutes to reconnect to that stream endpoint before we end the event. If you wanted to actually give a unique URL for each, like a unique stream URL for each event, then you would need to actually submit a new API request for each one of those streams.
All right. These questions are mostly to you, Matt. Can you provide VOD assets for all selected output qualities?
Yes, absolutely. So what we're going to do is just take the input stream. So what we always suggest is the highest quality input stream you can send. So the bandwidth that you have available to you, send us the highest quality input stream, at least the highest quality, and that quality needs to be at least that of the highest quality output you have, for obvious reasons. So what we'll do is take that input stream and transcode it, but if you wanted different quality renditions from that, then you could just do, from that point it's just a standard Encoder API request with that input stream FLB as the input file. So you could specify the first one with no settings, and that's just going to essentially transmux that, or not transmux, but it's essentially going to use the same quality as the input stream and give you an MP4, and then you could create other VOD assets the same exact way, but at different resolutions or whatever else you wanted. But yeah, so think of it like just a normal file-based transcode at that point, but the input is the raw live stream. So you can create as many different quality renditions off of that as you would like.
All right, thanks, Matt. And can we create the stream API request in advance to a live event? And how long does the live event job stay active on Encoder?
So this goes back to what I was, how I answered the conference event. So there's two big settings that you can use for this. By default, you've got, I think it's 30 seconds, 45 seconds. I'll have to double check on that. But you can set an event length, which means you could say, I want my event to last for an hour. And then you could start streaming at any point. So you could send your API request, and as long as you start streaming at any point within that hour, then you're fine. So we have a lot of customers that do just that. They know they're going to have a 2-hour event. Once you start streaming, the event length doesn't matter anymore. That's literally just like the amount of time we'll hold open the stream endpoint. So it really has to do more with connecting than it does with like the actual event length, because we won't close an event while you're still publishing a stream to it. So what we have is a lot of customers set that event length to the setup time they want. So they want to set up an event 30 minutes before, so they'll set their event length to say 45 minutes, so they can get their event set up 30 minutes before, set everything up, test it, disconnect, and then just reconnect 30 minutes later to start their live stream. So, or you can set reconnect time, which is similar, but that's every time you disconnect, you have the amount of time specified in your reconnect time to reconnect. So say you knew you would be disconnecting for 2 minutes at a time. By default, it's after 30 seconds we'll close the stream. So then you'd have 2 minutes every time. So you can go either way. Generally, I suggest the event length just because it's a little bit more like set in stone, I guess you could say.
Thanks, Matt. We have a very engaged crowd today, so I have a few more questions for you. Do the raw TS segments persist on our S3 bucket after the streaming event?
Yes. And actually, this is something we were thinking about going into, and we didn't for time constraints. But generally, what I suggest doing is taking that archive and pushing it to, so essentially you'd have 2 buckets set up, a live event bucket and then like an archival bucket. So specify your archive assets to go directly to that archive bucket, and then just set up a bucket policy on your live events bucket that clears everything out every day or something like that, or however long after the event you want, and that way you don't just end up persisting these TS segments for forever. And I generally would suggest providing like the static asset for archival purposes. But yes, the TS segments will persist for as long as you leave them there.
Thank you very much, Matt. And we do have questions coming in, so I think it's time for us to wrap up and answer all remaining questions via email. Everybody will hear back from Brightcove with the answers to the questions. And at this point, I would like to thank everybody for attending this webinar. Thanks to our presenters, Matthew from Encoder, a Encoder Developer Evangelist with Brightcove, and John Mancuso with the AWS. And our attendees, thank you very much for taking the time. I hope the information was useful. And before you log off, we have a very brief survey for you that we appreciate if you fill it out just so we can improve ourselves. And again, thank you for attending. And this concludes today's Amazon Web Services Partner webcast.